The fourth example, what we're going to do is we're going to use a matrix to solve a system of linear equations. I quickly shift to a matrix model as soon as we get three equations at three variables because it's an efficient and accurate way of doing that. And we've got technology that we can utilize, so we're going to look at using a matrix to solve this system. The first thing I'm going to do is transform this equation that's in an algebraic model into a matrix model. So to transform it into matrices, I want to create a coefficient matrix. So a coefficient matrix is going to be the coefficients of x, y, and z. And the coefficients of x, y, and z are 1, -2, 1. Second equation is 2, 3, -1. And the third equation, they are 4, 10, and -5. That's our coefficient matrix. We want to multiply that matrix times, so I'm going to transform it into a matrix equation, x, y, z, and that's going to equal our constant matrix. So the constant is our other side of the equation, the right side, 15, 7, and -3. So I've transformed our normal equation into a matrix equation, and just to represent this a little bit easier, I'm going to change this matrix into matrix A, and I'm going to type that into our graphing calculator. A is the matrix we're going to multiply times our variable matrix, and a lot of times what we do is we represent the variable matrix with the variable x, and that's going to equal, and most of the time we'll replace our constant matrix into matrix B. So basically I'm naming this matrix A, this is matrix X, and this is matrix B. In order to solve a matrix equation, what we want to do is we want to solve for the variable matrix. So that means we want to do the inverse of multiplying by matrix A. Well, there is no division in matrices, so what we end up doing is we end up multiplying both sides by the inverse of matrix A. Inverses reduce. So we'll be left with just matrix X, which is a variable matrix. And we also have to make sure that we take A inverse times B matrix in this order, because matrix multiplication is not commutative, which means I don't have the luxury of mixing these around and getting the same answer. So when you do this, always make sure you do your A inverse first, then times matrix B. So now what I got to do is I have to enter these things in my graphing calculator so that we can do the calculation of A inverse B. So that's going to be a little bit of review on how to get to your matrices. So go second, matrix. We want to edit a matrix, and I'm going to have that matrix A. Now matrix A it's not a 1 by 1, it's 3 rows by 3 columns, so it's a 3 by 3 matrix. Then we simply type in our coefficient matrix of 1, -2, and then 1, 2, 3, -1, 4, 10, and -5. Okay, so now we've entered all of our entries into our matrix A. We also have to load in our values into matrix B. So I'm going to go back and go second, matrix. This time I want to load or edit a matrix B, so I'm going to go down and select it and edit. I guess I got to go to edit first, then matrix B. Now this matrix is 3 rows and only 1 column, so I need to make that a 3 by 1, and I got to slide that over a little bit. And this is our matrix B that we're going to enter into it, so we hit enter, enter. I got to put a 15, a 7, and a -3 into our matrix B. Okay, so what I've done is I've put in matrix A and matrix B into the graphing calculator. So now I'm going to go second, quit. I'm going to go back to the home screen, and now what I want to do is I want to get the matrices A and B and multiply them together, but I want to do A inverse. So we'll go second, go to our matrix where we grab the name. I really want matrix A, and I want the inverse of matrix A, so I got to put the inverse on matrix A and then take that times matrix B. So second, matrix, go get the name for matrix B, and we're going to ask the calculator to do that calculation, and what we get is our answer matrix. This is what our variable matrix should equal. It says it should equal, let's see if I can get that to slide. Okay, just can't. For what reason, I'm not sure. There, I got a little more room. Bring the calculator back up. it says that our matrix X, which is our variable matrix, should be equal to 8, -2, 3. Now our variable matrix X was the matrix X, Y, and Z, so in essence what I can do, put this away, slide this down, I can replace variable X with the X, Y, Z matrix, which is going to tell us that our matrix X, Y, Z is equal to 8, -2, and 3. So now instead of the ordered pair, our ordered triple is going to be 8, -2, and 3. This is going to be a three-dimensional figure where you're looking in 3D, but it's going to meet, these three lines will meet at one location out in space. So one to review using your matrix model to help you solve these that are a 3x3 system. That's basically what I'm going to have you do when I evaluate your skill on solving a 3x3. And like I said, that makes things a little bit easier if you can apply that technology.